Hi, this is Mrs. La Barbara. This is Regents Physics, Chapter 7, Work, Power, and Energy, Video 4. Today's topic is Hooke's Law. The objectives are know the equations of Hooke's Law, understand the meaning of elongation, understand the relationship between force on a spring and elongation of the spring, be able to calculate force on a spring, and be able to determine the spring constant from the force versus x graph, or force versus elongation graph. Force on a spring. When a force is applied to a spring, the spring extends or compresses a specific amount, provided the elastic limit of the spring is not exceeded. The compression or elongation of the spring is directly proportional to the applied force. This is called Hooke's law. Fs equals to Kx. Here is the graph. So when you have one force, one weight, it elongates x. This elongation is the new length minus the original length. This Fs is applied force. In this case, applied force is mg. So let's take a when you apply mg, the x, you elongate x. When you double the force, you elongate 2x. So force is directly proportional to the elongation or compression. X is new length minus original length. This is new length minus original length. That's the x. K is called a spring constant. It is a property of the spring. Its unit is Newton over meter. Stiffer springs has bigger K value than a weak spring. So here, the force is mg. Over here, the force is 2mg. 2mg result elongation of 2x. mg result elongation of x. The slope of force versus elongation is k. The slope of elongation versus force is just 1 over k. So spring force is directly proportional to the elongation of the spring. Slope equals to f over x. Remember f equals to kx, so f over x equals to k. So here is f versus elongation, slope is k in newtons over meter. If you have a graph of x versus f, then that slope, x versus x divided by f, that is 1 over k. So this is elongation versus force, and this slope is 1 over k, which is meter over Newton. Let's take a look at this example. Given the following data table and corresponding graph, calculate the spring constant of this spring. Here's the data table, here is the graph. So the spring constant is the slope. Remember, in order to calculate the slope, we must always use the data on the graph. So we can't use this data. All the others are questionable. Even this one, it barely touches. So the best data to use is this 0, definitely on the graph. The last point is also on the graph. Those are the points I'm going to choose to use. You must choose the points on the line. So those are the points I'm going to use. So k equals the change of f divided by change of x. Those are the points. This is 2.5. That's the last point. That's the force minus 0. Divided by the elongation x is 0.046. Right over here. Minus 0, so the answer is 54 newtons per meter. Another example, a 20 Newton weight is attached to a spring, causing it to stretch as shown in the diagram. What is the spring constant? So Fs equals to Kx. So what is Fs? In this case, the weight is the Fs. What is x? X is the elongation, is the how much it has changed. So originally has 0.5 meters. Now you have 1 meter. So it elongated 0.5 meters. Plug everything in. K equals to 40 newtons per meter. Another example, a mass of 0.55 kilograms attached to a vertical spring stretched the spring 2 centimeters from its original equilibrium position. What is the spring constant? So in this case, Fs equals Kx. What is Fs? Fs is the weight of the mass. The weight is mg. The weight is m times g, which give you 5.4 newtons. What is x? X is 2 centimeters. You have to convert centimeters to meters. centi is 10 to the negative 2, so you just use 2 times 10 to the negative 2 meters. What is K? Plug everything into the equation. K is 270 Newton over meter. Okay, take a look at this graph. The graph below shows elongation versus force. Remember, in elongation versus force, the slope is 1 over K. So how do you compare the spring constant of spring A to B? Since spring, this slope is 1 over K, so the bigger the slope means the smaller the K. So compared to spring A, the spring B has smaller slope, has a bigger K. So the constant for B is bigger, larger. Okay. In X versus F graph, slope represents 1 over K. So that means B is larger. Which graph best represents relationship between elongation of the spring whose elastic limit has not been reached and the force applied to it, when the force applied? So that is direct relationship. That's Hooke's law. So the answer is C. So this graph represents elongation of the spring as a function of force. What is the value of the spring constant? So again, elongation versus force. Spring constant equals to force divided by elongation. So you'll have to use force divided by elongation. You can choose any point on here. This 3 divided by 0.3, that's 10 Newton over meter. So the answer is 10 Newton over meter. The last one. Okay, that's it for today. Thanks for watching. See you next time.